Hello guys, welcome to today's video. In today's video, we'll be talking about the different type of aircraft engine. Aircraft engine is a component of propulsion system for an aircraft that generate mechanical power. They are either lightweight piston engine or a gas turbine engine. In commercial aviation, the major players in turbofan engine, which I'll explain in a short while, are the General Electric, Rolls-Royce, CFM International, and the Pratt & Whitney, which is a major manufacturer of a turboprop engine. The first engine which we'll be talking about today is a piston engine. A piston engine converts linear moment into rotational moment by a rotation of a crankshaft. In a piston engine, there are 4 strokes, namely intake, compression, power, and exhaust. During the first stroke, which is the intake stroke, crankshaft pulls a piston down, creating a vacuum. This vacuum draws a mixture of fuel and air through the intake valve. During the compression stroke, crankshaft continues to spin, pushing the piston back, and that compresses the mixture of fuel and air. Before the piston hits the very top, the spark plug fires. During the power stroke, this ignition pushes the piston down, causing the crank to rotate. During the exhaust stroke, this forces the exhaust from the ignition out of the cylinder. The different type of piston engine are the horizontally opposed piston engine, the inline engine, the V-type engine, and the radial piston engine. The next, what we'll be discussing is about the type of gas turbine engine, which are the turbofan engine with low bypass and high bypass ratio, the turboprop engine, the ramjet engine, and the newly developed engine which is still in the research and development, which is a synergetic air-breathing rocket engine. A gas turbine engine, which is also called as a combustion turbine engine, is a type of continuous engine. Gas turbine engine works on Brayton cycle, where the gas turbine engine derives a power from burning fuel in a combustion chamber and using the fast-flowing combustion gas to drive a turbine. A simple gas turbine is comprised of 3 main sections: a compressor, a combustor, and a power turbine. The compressed air is mixed with the fuel and burned under constant pressure condition. The resulting hot gas is allowed to expand through a turbine to perform work. The animation shown here is a turbofan engine with high bypass ratio. Bypass ratio is a ratio of mass flow of air bypassing the engine core divided by the mass flow of air passing through the core. 10:1 means 10 kg of air that bypasses a duct for every 1 kg of air passing through the core. Afterburner is used in jet engine or military subsonic aircraft. Afterburner increases the thrust without any additional weight of engine, but at the cost of high fuel consumption and decreased fuel efficiency. Afterburner injects fuel downstream of turbine and reheat the gas. As a result, temperature rises in the tailpipe and gas is ejected through the nozzle at a higher velocity. Mass flow is also slightly increased because of the addition of the fuel at the end. The next, which is called the turboprop engine, works similar to that of a turbofan or a turbojet engine. The only difference is that the hot combustion gas, after expanding to the turbine, the rest is being transmitted to the reduction gear shown in the yellow color, and then to the propeller. The further expansion of gas occurs in the propeller nozzle, where the gas exhausts to the atmosphere. The next is ramjet engine, is another type of air-breathing engine which requires engine's forward motion to generate thrust. Ramjet cannot move aircraft from standstill, but they work efficiently at supersonic speed at around Mach 3. That is why they are used mainly in missiles. Ramjet engine mainly consists of a diffuser, combustor and a nozzle. The air entering the diffuser at supersonic flight velocity is terminated by a strong normal shock to bring the air velocity to a suitable level for the combustor. In the combustor, since there is no downstream turbine, a ramjet operates at stoichiometric fuel air ratio for the kerosene. Overfueling the combustor results in substantial drop in engine airflow and net thrust. The next engine which I'll be talking about is still in the research and development stage, and this is called as a synergetic air-breathing rocket engine, where a propellant used are air or liquid oxygen and liquid hydrogen. This engine has got a pre-cooled jet engine and works inside a closed cycle of a rocket engine. In an air-breathing mode, the turbocompressor with the lightweight air pre-cooler is positioned just behind the inlet con. At high speed, the pre-cooler cools the hot compressed air, which could reach a temperature that could not be withstood. The compressed air is then fed to the rocket combustion chamber, which is ignited with another propellant called as liquid hydrogen. This high pressure ratio provides a high thrust. After reaching an altitude of about 30 km, the system continues like a closed cycle high performance rocket engine, burning liquid oxygen and liquid hydrogen stored on board. Thank you.